Okay, let's get into it. Number 10. The red rectangle. Look at almost anything in deep space, and it's soft. Clouds, smears, spirals that trail off into nothing. Space doesn't do edges. It doesn't do corners. And then there's this thing. Out in the direction of the constellation Monocerotis, the unicorn, there's a dying star with the unglamorous catalog name HD 44179. And wrapped around it is a shape that, the first time you see it, makes your brain quietly file a complaint. Because it's a rectangle. A glowing red geometric rectangle crossed by a giant X with a series of straight horizontal lines stacked inside it like the rungs of a ladder. We call it the red rectangle, and it looks built. Here's what's actually going on. That's not one star, it's two. A close binary orbiting each other inside a thick donut of dust. As the system dies, it's puffing out material, and we happen to be looking at that outflow almost perfectly edge-on. The X is the walls of two cones of gas billowing out above and below. And the rungs, those impossibly straight lines, are the rims of expanding shells. Seen edge-on, so their curved edges flatten into what look like drawn lines. Some astronomers describe them as looking like a stack of wine glasses seen exactly from the side, so the rims read as straight bars. But here's the thing. Those rungs seem to have been laid down at intervals. Puff. Wait a few hundred years. Puff. Like the star has a pulse. So what you're looking at isn't a structure so much as a recording, a timeline of a star's death written out in evenly spaced lines, and your eye reads that regularity as a message. It isn't a message, it's physics. But it's physics wearing the mask of design, and that's what makes it land. Nature isn't supposed to draw straight lines. Here, it drew a ladder. And the strangest part is that this is our future. Our sun will do a gentler version of this someday, throwing off its outer layers into a glowing shell. It just probably won't be polite enough to make it look intentional. For now, the red rectangle just hangs there in the dark, a dying star inside a shape it has no business making. Order, where there should only be smoke. Number 9. The hand of God. Your brain is a pattern machine. It's so good at finding faces and shapes that it finds them where there are none, in clouds, in wallpaper, in burnt toast. So you should be suspicious of yourself when you look at this next one. And you'll still see it. Everyone sees it. About 17,000 light years away, there's a cloud of energized gas that is shaped exactly like an open human hand. Fingers, a palm, a thumb, reaching out across space toward a small, glowing cloud, like it's about to pick it up. Astronomers call it the hand of God, and when NASA's X-ray telescopes imaged it in high-energy light, the hand didn't get less convincing. It got worse. There are the fingers, splayed out. There's the bright knuckle region, and down at the wrist, there's a single point of light. That point of light is the thing doing all of this. It's a pulsar, a neutron star called PSR B1509-58. And I want you to sit with what that is for a second. It's the leftover core of a star that exploded about 1,700 years ago. It's only about 12 miles across. You could drive across it in the time it takes to get through a mid-sized city if it didn't instantly vaporize and crush you. It spins nearly 7 times every single second, and its magnetic field is something like 15 trillion times stronger than Earth's. That corpse is one of the most powerful electromagnetic engines in the entire galaxy, and it's blowing a wind of particles out into space at a ferocious speed. Those particles follow the invisible lines of its magnetic field. And the shape those field lines happen to trace when lit up in X-rays is a hand. So here's the unsettling part. The hand isn't real. There's nothing solid there. What you're looking at is the shape of a magnetic field. You are seeing something that is normally invisible, the geometry of pure force, and it just so happens to look like a hand reaching for something. The fingertips are pointing at a separate cloud of gas called RCW89, lighting it up where they touch. A dead star, throwing the shape of its own magnetism across 150 light years, and the universe pressing that shape into the outline of a hand. We don't know why space keeps doing this to us. Making corpses that reach. Number 8. V838 Monocerotis. In January of 2002, a faint star nobody was paying attention to, back in Monocerotis again, suddenly got bright. Not a little brighter. It flared up until it was briefly one of the most luminous stars in the entire Milky Way, something like 600,000 times brighter than our sun. And then, within a few months, it faded back down and went quiet. That alone would be a footnote. Stars flare. What happened next is why we're talking about it, because that flash of light didn't just vanish. It kept traveling outward, and it started hitting shells of dust that were already floating around the star. And as it hit each shell, that dust lit up. So when Hubble pointed at V838 Monocerotis over the following months and years, it saw something that looked like the star was exploding in slow motion. Great glowing shells of dust, blooming outward, wider and wider, an expanding sphere of light rolling out into space. It is one of the most beautiful things Hubble has ever photographed. And it's a ghost. Here's the thing. Nothing is actually moving out there. The dust isn't flying anywhere. What you're watching in those images taken from 2002 to 2004 is just the flash of light sweeping across dust that was already sitting there. It's called a light echo. Imagine standing in a dark, dusty cathedral and setting off a single camera flash. For a fraction of a second, the light races outward and illuminates the pillars farther and farther back. That's this. Except the cathedral is light years across, and the flash takes years to cross it. So the expansion is an illusion, a trick of timing. You're not watching an explosion. You're watching a single instant, one bright moment that already ended, being slowly revealed to you as its light finds new dust to touch. And we still don't fully know what made the star flare in the first place. The leading idea is that two stars merged, slammed together, and the collision lit the sky. But the star didn't blow itself apart the way a normal outburst would. It just briefly swelled into a monster and then shrank back. So, we have a picture of an explosion that wasn't an explosion, expanding through space without anything moving, showing us a moment that's already gone. Deep space is full of things like this. Light, still arriving from events that ended a long time ago. Number 7. Hanny's Voorwerp. In 2007, a Dutch schoolteacher named Hanny van Arkel sat down at her computer to help out with a project called Galaxy Zoo. The idea was simple. There were more galaxy images than professional astronomers could ever sort through, so they asked the public to help classify them. Spiral or elliptical. Just look and tag. And Hanny, going through her images, found something that wasn't supposed to be there. Underneath a spiral galaxy, there was a big, glowing, green blob. No obvious source, no label, just a ghostly green cloud sitting in space. She flagged it and basically asked, "What is this thing?" Nobody knew, so they named it after her. Hanny's Voorwerp. Voorwerp is just Dutch for object. Hanny's object. When astronomers turned serious telescopes on it, the answer they found was genuinely eerie. This green cloud is enormous, about the size of a small galaxy, with a huge hollow gap in the middle, more than 16,000 light years across. And it's glowing because it's being lit up. Something blasted it with radiation, energized its oxygen, and made it shine that cold emerald green. The problem is, when they looked for the thing doing the lighting, at the heart of the nearby galaxy, where the light should be coming from, there wasn't enough there. The engine was too quiet. The floodlight was off. Here's what they think happened. That galaxy used to host a quasar. A quasar is a supermassive black hole in the middle of a galaxy, feeding so violently that it outshines everything around it, one of the brightest objects in the universe. And within roughly the last 70 to 100,000 years, that quasar shut down. It went dark, but the last light it ever put out is still traveling. It's still crossing that giant cloud of gas. So the Voorwerp is glowing from a light source that no longer exists. It's an afterimage, like when a camera flash goes off in your face, and you keep seeing the bright spot for a few seconds after. Hanny's Voorwerp is that spot, burned into space, still glowing from the death of a monster that already went dark. A schoolteacher, clicking through images on her home computer, found the ghost of a quasar, and it's still there. Still green, still waiting for the news of its own light source's death to finish arriving. Number 6. The Black Widow Pulsar. Some of the disturbing things out there are disturbing because they're violent. This next one is disturbing because it's patient. There's a system with the name PSRB 1957 plus 20, and it's 2 stars. One of them is a pulsar, the same kind of object we talked about with the hand, the tiny spinning corpse of a dead star. This one spins hundreds of times per second, and right next to it, locked in a tight orbit, is a small, living companion star. I say living, but only barely, because the pulsar is killing it. The dead star is throwing out a constant, howling wind of radiation and high-energy particles, and that wind is hitting the companion and stripping it away, evaporating it, blasting its material off into space, bit by bit, atom by atom. Astronomers watched this happen and gave the system its name, the Black Widow, because it's a partner slowly destroying the partner beside it, and the details are where it gets under your skin. The companion is small, and because the pulsar is always facing it with that blowtorch of radiation, the little star has a permanent day side and a permanent night side. The side facing the pulsar is scorched to something like 8,300 degrees. The side facing away sits down around 2,900. It can't turn away. It can't cool down. It just hangs there, one face burning, one face frozen, being slowly worn to nothing. We can actually see it happening in the radio signals. For about 1/10 of every orbit, the pulsar's beam gets blocked, eclipsed, by the cloud of gas being boiled off the companion. We are watching the murder weapon leave fingerprints, and the time scale. The companion loses only a tiny sliver of itself each year. At that rate, it'll take about 1 billion years to be completely evaporated. 1 billion years of being cooked alive, one atom at a time, by the corpse of a star that already died. Once. That's the part that stays with me. The pulsar is already dead. It died in a supernova long ago. And in death, it's killing again, slowly, methodically, with no hurry at all. Deep space doesn't only contain disasters. Sometimes it contains something worse. Patience. Number 5. The Pillars of Creation. You know this image, even if you don't know you know it. 3 enormous columns of dark, greenish gold, gas and dust, rising up like towers, with pinpricks of newborn starlight sparkling at their tips. Hubble took it in 1995. It's on posters, textbook covers, dorm room walls. It's called the Pillars of Creation because inside those towers, brand new stars are being born. It might be the most famous photograph of space ever taken. And there's a real chance you're looking at something that no longer exists. The pillars sit inside the Eagle Nebula, about 7,000 light years away. And when NASA's Spitzer Space Telescope looked at the same region in infrared light, it saw something the pretty picture doesn't show. Right next to the pillars, there's a cloud of hot dust. And the shape and temperature of that dust looks a lot like the scar left behind by a supernova. An exploded star. So here's the scenario that some astronomers pieced together. A nearby massive star went supernova, and the shockwave from that explosion, a wall of energy expanding outward, is heading straight for the pillars. In fact, they calculate it may have already reached them and knocked them down, blown them apart, roughly 6,000 years ago. Now hold on, you might say. If they were destroyed 6,000 years ago, how are we still looking at them? Because of the delay. The pillars are 7,000 light years away. The light leaving them right now takes 7,000 years to cross the gap to Earth. So the light we're seeing today, the light in that famous photo, left the pillars before the shockwave hit. We are looking at old light. We're seeing them as they were, standing, intact, thousands of years ago. And if the supernova scenario is right, the wave of their destruction is also traveling toward us in that same old light, and it won't arrive for another 1,000 years or so, which means somewhere out there, right now, there's a version of that image where the pillars are gone. Rubble. And it's on its way to us, and nobody alive today will ever see it. I should be honest with you. This is debated. At least one astronomer pushed back, arguing that a real supernova should have left stronger radio and X-ray signals than we've picked up, and that the dust might just be heated by the winds of living stars instead. So the pillars might still be standing. We genuinely don't know. But that's almost the most unsettling part. The most famous thing we've ever photographed in space, and we can't tell you for sure whether it still exists. We're looking at a portrait, and we don't know if the subject is alive. Number 4. The star that was eaten. We talk about black holes constantly, but we almost never get to watch one do the thing black holes are famous for: eating. Usually it happens hidden, or already finished, or so far away it's just a flicker. In 2019, astronomers caught one in the act. Up close. Early enough to see the whole thing. Here's the setup. In a spiral galaxy about 215 million light-years away, in the constellation Eridanus, an ordinary sun-like star wandered too close to the supermassive black hole at the galaxy's center, and the black hole's gravity did what its gravity does. It grabbed the side of the star nearest to it far harder than the side facing away. That difference in pull is the killer. It stretched the star, and I don't mean gently. The star got pulled into a long, thin stream of glowing gas, drawn out like taffy, like a strand of spaghetti. Astronomers actually use that word for it: spaghettification. It sounds almost funny until you picture an entire sun being pulled into a noodle of superheated plasma and unspooled into a whirlpool of gravity. The event got the name AT 2019 QIZ, and the reason it matters so much is timing. They spotted it just after it started, so for the first time, they got a clear view of the whole process. Half the star's material got flung back out into space. The other half spiraled inward, circling the drain, heating up, screaming in light across the spectrum. And as the black hole started to feed, it threw up a curtain of gas and debris, blasting outward at speeds up to 10,000 kilometers per second. That curtain turned out to be the answer to an old mystery. Whenever we'd tried to watch a star get eaten before, the view was murky, dimmed, blocked. Now we understood why. The black hole veils itself in the wreckage of its own meal. It pulls a curtain of debris across the scene as it eats. This time, we caught it before the curtain closed. So think about what that image actually is. A star. A whole star. A thing like our sun, with everything that implies. Unspooled into a ribbon and swallowed, live, on camera, from 200 million light years away. Not a simulation. Not an artist's impression. A real event that really happened, watched by human beings. The star had a life. Maybe planets. And in a matter of months, it was pulled into a thread and gone. Deep space doesn't grieve. It just eats and pulls the curtain and moves on. Number 3, the zombie star. Everything we've talked about so far follows the rules, even when the rules are horrifying. Stars die. Black holes eat. Light lies about timing? Fine. This next one breaks a rule that isn't supposed to bend. The rule is this. When a certain kind of star explodes as a supernova, it dies. Completely. A supernova is the single most violent event in the universe, short of the birth of a black hole. When a white dwarf detonates, it's supposed to tear itself to shreds. There's no body left. Nothing survives. And then there's a supernova called SN 2012Z. Astronomers had a rare piece of luck with this one. Hubble had already photographed that exact patch of sky years before the explosion, so when the star blew up, they could go back and look at what had been sitting there. They found the culprit, a white dwarf paired with a hot blue companion star. That's already unusual. We almost never catch a supernova's parent star in the act of existing beforehand. But then they kept watching, and when the explosion faded, they went back to look at the spot where the white dwarf should have been vaporized, erased, scattered across space. It was still there. Not only was it still there, follow-up observations found that the surviving star was actually brighter than it had been before the explosion. It detonated, and it came back stronger. We call these zombie stars. An SN 2012Z is one of the best examples. It belongs to a weird, faint category called Type IX supernovae, and we've now found more than 30 of them. The current thinking is that these are partial detonations. The white dwarf blows off some of its material, gets kicked hard by the blast like a rocket firing, and instead of being destroyed, it puffs up, swells, and ends up glowing brighter than before. A star that ate its own supernova and walked away. I want you to feel how wrong that is. Imagine watching a building get demolished, the whole thing going up in a fireball, and when the smoke clears, the building is still standing, and it's taller than it was before. That's what this is, on the scale of a star. We're still arguing about exactly how it works. But the observation itself is not in doubt. A star exploded, and it survived. Out there in the dark, some things don't even respect death. Number 2, the star that vanished. Let me tell you about a star we were watching, that we knew was there, that we had studied for 10 years. And then one day, we looked, and it was gone. No explosion. No wreckage. No flash. Just an empty spot where a star used to be. The star lived in a small galaxy called the Kinman Dwarf, or PHL 293b, about 75 million light-years away in the constellation Aquarius. From 2001 to 2011, whenever astronomers looked at that galaxy, the light carried an unmistakable fingerprint. There was a luminous blue variable star in there. A giant. Something like 2.5 million times brighter than our sun. These stars are unstable. They flicker and surge, but they're bright, and they're obvious. In 2019, a team led by an astronomer named Andrew Allen pointed the Very Large Telescope in Chile at that galaxy to study the star in more detail, and the fingerprint was gone. The signature that had been there for a decade had simply disappeared. They looked again. Different instruments. Still nothing. The star was not there. Now think about the scale of what's missing. This wasn't a candle going out. This was a beacon, 2.5 million times the brightness of the sun, and it vanished without a sound. There are 2 explanations, and both of them are unsettling in different ways. The gentle one is that the star was just having one of its dramatic mood swings, dimmed down hard, and hid itself behind a cloud of its own dust. If that's true, it's still there, sulking in the dark, and it might brighten again someday. The other explanation is the one that keeps people up at night. That the star collapsed. That it ran out of fuel and fell straight in on itself and became a black hole without the supernova. No explosion, no fireworks. Astronomers call that a failed supernova. The star just quietly folds up and turns off. And where there was one of the brightest objects in a galaxy, there's suddenly nothing but a black hole and silence. We usually think of stars dying in violence. Enormous, skylighting death. But if that second explanation is right, then we may have caught something far quieter and far stranger. A giant star, dying with no last words. Here for a decade. Then just absence. And we still don't know which it was. Somewhere in the Kinman Dwarf, there's either a star hiding or a hole where a star used to be. We're still watching the empty spot, waiting to find out. Number 1. The first photograph of a black hole. For most of human history, the black hole was an idea, a consequence of equations, a word we used for a thing we were fairly sure existed, but had never actually seen, and by its very nature maybe never could see, because a black hole is defined by the fact that no light escapes it. How do you photograph the one thing in the universe that refuses to be seen? On April 10th, 2019, we did it anyway. To take the picture, astronomers built something called the Event Horizon Telescope. Not one telescope. 8 of them, scattered across the whole planet, from Hawaii to Spain to the South Pole, all pointed at the same target and linked together so precisely that they worked as a single instrument the size of the Earth itself. That's what it takes. To see a black hole, you need an eye as big as the world. And they aimed it at the heart of a galaxy called Messier 87, 55 million light-years away, where a supermassive black hole sits with a mass of about 6.5 billion suns. The image they got back is not sharp. It's a fuzzy orange ring, brighter along the bottom, wrapped around a circle of pure black. It looks almost humble, and it is one of the most staggering things our species has ever produced. Because that black circle in the middle is the shadow of the black hole. It's the region where light goes in and does not come out. And it is bigger than our entire solar system. You could drop every planet, the sun, all of it, into that dark spot and have room to spare. And that orange ring around it, here's the part that rearranges your head. That's not just a glowing disk sitting flat around the hole like a record. The black hole's gravity is so extreme that it bends light around itself. So some of the light you're seeing in that ring is coming from the far side of the black hole, from behind it, wrapped up and over and around by gravity and delivered to your eye. You are, in a real sense, seeing around the back of it, looking at something whose gravity is folding the light of its own surroundings into a halo. The scientist who led it put it simply. He said, "We have seen what we thought was unseeable." And I think that's the note to end on. Because every single thing we've talked about tonight, the hand, the ghost quasar, the star pulled into a thread, the beacon that vanished, all of it comes down to the same quiet, staggering fact. We are a species stuck on one small rock, with a short lifespan and soft eyes. And yet we have found ways to look into the dark and see the things that were never meant to be seen. We photographed the edge of forever. We watched a star die with no sound. We are still receiving light from towers that may already have fallen. Space is not trying to frighten us. It doesn't know we're here. It's just doing what it has always done, colossal and indifferent and old beyond meaning. The disturbing part was never out there. The disturbing part is that we keep looking anyway, and we keep seeing more. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.